Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video lecture, I am going to discuss about the different types of DC motors. So in previous session, I am discuss about the series wound DC motor and shunt wound DC motor. Now I am going to discuss about the compound wound DC motor. Okay. So here in this case, so we have to discuss about the compound wound DC motor. So right. So in previous case, so we have discussed about the series and shunt. Okay. So here basically, so we are having the different types of DC motors which are classified into two types. So in that, first one is the self-excited DC motor, another one is separately excited DC motor, right? So self-excited DC motor is classified into three types. So first one is series wound DC motor and second one is shunt wound DC motor, and this is third one. Third one is compound wound DC motor. Now the compound wound DC motor is classified into two types. So in that, first one is short shunt compound DC motor and second one is long shunt compound wound DC motor, right? So we'll discuss one by one. So here the compound wound DC motor. So this is third type in self-excited DC motor. So the compound wound DC motor which is classified into two types. So in that, the first type is short shunt compound wound DC motor. Okay. So here first of all we need to draw the circuit of the short shunt compound wound DC motor. Okay. So here in this short shunt compound wound DC motor we are having the armature winding, series field winding and shunt field winding. Okay. These all are connected in parallel connection. Okay. So here series field winding and armature, and here is the motor. So this is connected here. The shunt field winding is connected here, and this side we need to give the DC supply. Plus minus voltage is V. So now, and this is motor. For this motor having the back EMF, that is EB, and this is armature resistance RA, and this is series field winding, we are having the series field resistance, and for the shunt field winding having the shunt field resistance, right? For each and every winding we are having the sum amount of resistance is represented by armature resistance, series field resistance and shunt field resistance, right? Now for this we need to give the current direction. So we are having source here. From the source we are having the total current, that is I. So the total current of the circuit is I, and current through this RSC I am taking as ISC, means series field current. Through RSC we are having the series field current, that is ISC, and the total current towards this point, from this point current is dividing. From this node point the current is dividing. Now current through this RA is IA and current through this RSH is ISH, right? So here is the circuit is belongs to short shunt compound DC motor. So in this short shunt compound wound DC motor also we need to write the current, voltage and power relations. We need to write current, voltage and power relations of short shunt compound wound DC motor. Okay. So first current relations here. So what about the current relations? So I is there and current through RSC, ISC is there. So these two are in same line, means these I is equal to ISC. So first current relation I equal to ISC. So these two currents are same only. That is equal to, so this total current towards this node point. From this node point current is dividing, means we have to apply KCL at this node point. So KCL states that the algebraic sum of the incoming current is equal to the algebraic sum of the outgoing currents. So incoming current is I equal to, so algebraic sum of the outgoing currents are IA and ISH, that is equal to IA plus ISH. So total current I equal to ISC equal to IA plus ISH. Okay. So now we have to write the ISH equation, means shunt current equation. So in this, voltage drop in this branch, voltage drop, it is a parallel circuit. So these all are connected in parallel, right? In this parallel circuit, voltage drop in this branch is equal to voltage drop in this branch. So these voltages are same only because it is a parallel. Okay. So see, the voltage drop across the voltage drop in this branch is ISH RSH equal to voltage drop in this branch, that is V plus ISC RSC. So V plus ISC into RSC. Then ISH equal to V plus ISC RSC divided by RSH is the shunt field current. So shunt field current ISH is equal to V plus ISC RSC divided by RSH. So these are the current relations of given short shunt compound wound DC motor. Okay. Now we have to write the voltage relation. For the voltage relation, apply KVL in this loop. Apply KVL in this loop. So for that, I am starting from this point. I am starting from here. When I am starting from this point, always we need to take the second polarity. Second polarity is plus and voltage is V minus voltage drop at RSC is ISC RSC minus ISC into RSC, and voltage drop at RA minus IA RA minus, we are having the EB equal to 0. Then EB equal to V minus IA RA minus ISC RSC minus brush voltage drop is VB. Okay. So EB equal to V minus IA RA minus ISC RSC minus VB is the voltage relation of short shunt compound wound DC motor. Now power relation. The power from the source equal to V into I. Power from the source is PS is equal to V into I, and the mechanical power developed by the DC motor. The mechanical power developed by this DC motor is EB into IA. So EB into IA. These are the current relations, and this is the voltage relation, and here is the power relation of short shunt compound wound DC motor. Okay. So the second type of compound wound DC motor is long shunt compound wound DC motor. So see, for the short shunt compound wound DC motor and for the long shunt compound wound DC motor, so both are same only difference is connection. We have to remove the connection at this point 2, and we have to replace here. Remove the connection at this point and connect here. Now the circuit belongs to long shunt compound wound DC motor. Okay, here draw the circuit first. Series field resistance, so series field winding, armature resistance, having the motor. So here shunt field winding, it is connected to DC supply, plus minus voltage is V, and this is motor. So for this motor having EB, and this is armature resistance, and this is series field resistance, and this is shunt field resistance. Okay, at armature winding we are having the armature resistance, at series field winding having the series field resistance, at shunt field winding having the shunt field resistance. Now for this entire circuit we need to give the current directions, right? So from the source we are having the total current I. This total current is towards this point. The total current is towards this point. From this point current is dividing. So current is dividing. So current through RSC is ISC. Current through RSH is ISH. And here also the current through RA is IA, armature current IA. Okay, so here current through RSC is ISC, that is series field current, and current through armature is armature current IA, and current through shunt field winding is shunt field current, that is ISH. Right, now for this long shunt compound wound DC motor also we need to write the current, voltage and power relations, right? So first of all we need to write the current relations first. So in this current relation, series field winding and armature winding, so these two are connected in series. In series the current is constant, means IA is nothing but ISC only. So here IA is equal to ISC, that is armature current is equal to the series field current. Now to apply KCL here, apply KCL at this node point, means the algebraic sum of the incoming current is equal to the algebraic sum of the outgoing currents. So at this node point the algebraic sum of the incoming current, that is I, equal to algebraic sum of the outgoing currents, means ISH plus ISC. ISH plus ISC or I equal to ISH plus IA. Right, the total current I equal to shunt field current ISH plus armature current IA, or total current is equal to shunt field current ISH plus and series field current ISC. Right, similarly we have to calculate the ISH value. So in that case it is a parallel circuit. In parallel circuit voltage is constant here, right? So therefore the shunt field current ISH is equal to, so according to Ohm's law, so I equal to V by R. So in the place of I, ISH is there, in the place of V, so V is there, in the place of R, RSH is there. So then ISH equal to V divided by RSH is the shunt field current ISH. So here is the current relations of long shunt compound DC motor, right? So now we have to write the voltage relation. For the voltage relation we have to apply KVL in this loop. We have to apply KVL in this loop. So for that I am starting from here. I am starting from this point. So when I am starting from this point, always we need to take the second polarity. So the second polarity is plus, voltage is V, and at RSC, voltage drop at RSC is minus ISC into RSC, minus voltage drop at RA is minus IA RA, and For the motor having the back EMF, that is minus EB is equal to 0. Now find out EB. So EB equal to V minus, here IA and ISC both are same. So I am taking IA as a common here. So IA into RA plus RSC minus brush voltage drop, that is VB. Okay. So EB equal to V minus IA into RA plus RSC minus VB is the voltage relation of long shunt compound wound DC motor, right? And similarly, the third type is power relation. So power relation of the long shunt compound wound DC motor is, that is, power from the source. Power from the source is equal to V into I. Power from the source is V into I, and the mechanical power developed by the DC motor is equal to EB into IA or EB into ISC. So EB into IA or EB into ISC is the mechanical power developed by the DC motor. Okay. So these are the current relation and voltage relation and power relations of the DC long shunt compound wound DC motor. Okay. And next, the second main type is separately excited DC motor. So this is separately excited DC motor. So for the separately excited DC motor, so here we need to give the separate DC supply here. So here field winding, and here we are having the motor series with armature resistance is connected to the DC supply. So plus minus voltage is V, and this is RA, and this is EB. Now for the separately excited DC motor also we need to write the current, voltage and power relations. So first give the current directions for the circuit. So from the source we are having the total current, that is I, and current through RA is IA, that is armature current. So now first current relation. So here the entire circuit is a series circuit, means the total current is equal to the armature current, that is IA. So I is equal to IA, current relation, and voltage relation of the separately excited DC motor is, for that we need to apply KVL here. So for that I am starting from this point. When I am starting from this point, always we need to take the second polarity, that is plus V minus IA RA minus EB equal to 0. So plus V minus IA RA minus EB equal to 0. Then find out EB. EB equal to V minus IA RA minus VB, means brush voltage drop of the motor. Okay, here is the voltage relation. And power from the source is equal to V into Y, and the mechanical power developed by the DC motor is EB into IA or EB into I. Okay, these are the current and voltage and power relations of separately excited DC motor. Okay, so these are the different types of DC motor. Okay, so now we'll discuss the problem on long shunt compound wound DC motor. Okay, so here first we'll draw the circuit first here. So this is shunt field winding, and we need to give the DC supply here. So this is motor. For this motor having EB, and this is RA, and this is RSC, and this is RSH, and supply voltage is V and current is I. So from this point current is dividing. So current through RSH is ISH, current through RSC is ISC, and current through RA is IA. Right? So now a long shunt 600 volt, 1200 RPM DC motor has a series field winding resistance of 0.05 ohm, shunt field winding of 200 ohm, and an armature resistance is 0.1 ohm, and the machine draws 100 ampere from the supply. So we need to calculate the back EMF here. So here this problem is based on the long shunt compound wound DC motor. Okay, so here first of all we need to write the given data first here. So here the total supply voltage V equal to 600 volt, and speed also is there, N equal to 1200 RPM. So speed of the long shunt compound wound DC motor has series field winding. So here series field winding is given, RSC equal to 0.05 ohm, and shunt field winding RSH is there, RSH is equal to 200 ohm, and armature resistance, that is RA, equal to 0.1 ohm. Now the machine draws 100 ampere from the supply, means so here the current I also is given, that is equal to 100 amperes. Now we need to calculate the back EMF, that is EB. We need to calculate the EB value. So already we know EB equal to, the equation is V minus IARA minus ISC into RSC. So V minus IARA minus ISC RSC. So here the total voltage is given, V equal to 600. Now IA value. So here we need to calculate the armature current IA, and also we need to calculate the series field current ISC. But they are given armature resistance and series field resistance. So RA value is 0.1 ohm and RSC is 0.05 ohm. Now we need to calculate IA and ISC, right? So from this shunt wound DC motor, apply KCL at this point here. So in that case, ISC is equal to IA, because these two are connected in series. Then ISC equal to IA, and the total current I equal to IA plus ISH. The total current I equal to IA plus ISH, right? So now we need to calculate the IA value. If we can calculate IA, we will get the ISC also. So IA equal to I minus ISH. IA equal to I minus ISH, where ISH, we need to calculate the ISH value. So how we can calculate the ISH? That equal to, the equation is V divided by RSH. So V by RSH, that equal to, what is V? 600 by RSH is 200, that equal to 3 amperes. That is ISH value. Now substitute I value, ISH value. So I is there. Substitute I value and ISH value in this equation. We'll get IA. So therefore Ia equal to I. What is I here? 100 minus ISH is 3. That is equal to 97 amperes is the armature current. Now armature current is nothing but ISC also. Now substitute all the data in this equation. We'll get EB value. So here EB equal to V 600 minus IA. What is IA value? 97 into RA value. What is RA? 0.1 minus ISC. What is ISC? Again 97 into RAC. What is RAC value here? 0.05. Now by solving this equation we'll get 585.45 volts. Here is the back EMF of, that is 585.45 volts of long shunt compound wound DC motor. Okay, here is the different types of DC motors and problems on types of DC motors. So thank you one and all.